Morning everyone. This is Satish from Vishakhapatnam. I'm a faculty of physics, MSc Physics, and I have been teaching physics more than 10 years. Okay, today a simple video lecture that I'm presenting in front of you. So for that I'm taking a simple topic from Newton's laws of motion, NLM, and but of course it is very important and we have many questions regarding this concept, especially in competitive examinations and both in NTSC board level and also competitive and professional courses like NEET and JEE, etc., etc. And now coming to the point, so I'm going to explain about that conservation of momentum. Conservation of momentum. So for this we need to have an idea what is it momentum basically, and then what is the conservation. We adopt the word term for the conservation of momentum. It actually momentum is a simple mathematical formula we can design for that. What is that? That mass multiplied by velocity of any body, any moving body, we can say, so that is simply momentum it is. So for the representation we have that P and mass multiplied by velocity, that which is a pure vector quantity, being it is multiplied and obtained with the velocity which is also a vector quantity. And apart from this is the mathematical analysis for that momentum concept it is. And actually what actually that momentum of a moving body represents, it's a good idea to understand. For example, we see, suppose if we strike a striker in a caroms board with external force, then what is happening? It is going to shatter all the coins whatever it is along its path. So therefore their respective positions will also be changing. So that we can say not even that mathematical approach of momentum mass multiplied by velocity. Momentum itself, it is the strength of motion. It's a theoretical meaning, basic meaning of momentum of a body is. It shows that what heaviness, or simply we can say that quantity of motion of a body. So the quantity of motion of a body can be represented by the momentum itself. That is the significance of this physical quantity in the field of mechanics, and which is an important physical quantity which influences many factors, and it is useful to simplify this lot more typical conditions as far as this chapter concerns Newton's laws of motion. Okay, anyways, so therefore we will see what is the conservation meaning it is. As conservation, it's in this simple, for the student level we can say no change at all. So conservation itself we can say that is no change at all. Means, for example, if any process is happening, so before and after that process nothing can be changed unless some external influences acting over the entire system it is. So meanwhile we'll see what is that system itself. So there is a lot of confusion in the students what is how to understand the system itself it is. For example, if we take that least part of any matter, we can say simply according to our basic knowledge, molecule is the least part. Itself molecule contains a group of atoms together. So therefore if you take a smallest part of matter, which is we call frequently molecule, it composed of atoms. So therefore molecule itself can be chosen as system itself because it contains atoms itself. For example, two balls. So a ball, of course it may be whatever the matter inside it is, a ball we are simply showing to the students. So it is a body. For example, if you take two more balls like that, it is a system of two balls. So therefore like that, any number of bodies can be entered in a system. Even a single body can be taken isolated system because being it is composed of many number of molecules it is. That is the meaning of system it is. Simple meaning for the system it is. So therefore in any system what is happening, if the system is taken to be conserved, if the system is considered to be conserved, then what happens? No change at all, and before or after a simple process, physical process, okay, unless it is acted upon by external forces like that. For example, very better way to understand for the students, suppose I'm having a duster in my hand. Suppose this is a system, if I choose, then what happens? Unless it is acted upon by external forces, it doesn't change like that. So therefore any system, any isolated system, even a single matter, single ball, single bodies, single shot or whatever it is, unless it is acted upon by external forces, no physical changes can be happened around itself. That is what we call isolated system. And the system, how when we can say that is conserved, then simply there is no change in it is. For example, another better way of explaining this conservation with a simple diagram. For example, here I have taken a carom board, suppose, or billiard boards itself. okay, is having a number of balls placed at different places, and I'm having, or these are coins on a carom board, and I'm having a striker with me. Suppose if I hit this coin, this direction is going to shatter this direction, and the striker will keeps on moving towards this and maybe move towards this, whatever it is happening. So simply, irrespective of the force applied on the striker itself, suppose if you say this complete board as a system, then what actually it is happening? The striker is applying force on the coin which is inside the system, and the coin itself applying on the margin of the board, and it is inside the system itself. Again, striker going to this coin, and the coin may expect to be going this way, and striker coming to this. So that whatever it is happening, whatever the direction of shattering of the coins along with the striker, it is doesn't matter. But what is happening? Everything is happening inside the system of carom board. That is what the system itself meaning is. So therefore, what is happening? No external forces acting on the system. Therefore, what is happening? Only the particles which belongs to the system are moving in different directions, whatever it is. So simply we can say no external force is acting on the system. So if such cases arise, then what actually it happens? If there is no external forces acting on any system, then what happens? No change in that so far concerned physical quantity. I repeat, no change in that so far concerned physical quantity, in the sense momentum here. So therefore, that what actually the conservation of momentum tells us. Okay, so therefore, what we can conclude with this observation? If there is no external force acting on any system, then there is no change in the momentum itself, which leads to a many number of the scientific cases to resolve, many number of competitive cases to resolve, many number of minds to be got clarified with this principle, right? So this is simply that conservation of momentum, what is all about. So therefore, simply we can once again repeat ourselves: there is no external force acting on the system, the total momentum of the system is same, or in books we can say this total momentum of the system is constant. For example, we'll take a simple situation to demonstrate this completely. For example, if I say a box or something is another body is at rest, so its initial momentum, it is at rest, in the sense its speed is, its velocity is 0. Okay, therefore we can say the initial momentum of the system what we have chosen is nothing. Okay, so if any process is happening inside the system itself, then what it should happen after, even after the process, that total momentum of the system must be same. Means initially if it is 0, and therefore finally it must be 0. That is what all about the law of conservation of momentum is concerned about. Okay, so I hope that it is clear to you all. And then coming to the point, so where there we have a number of applications basing on this applications, even the books and corporate sectors, wherever it is, whatever the book you take, number of applications basing on this concept, which definitely influences the complete chapter Newton's laws of motion. I am sure for that. So then I am taking an example application for this application. See, for the better understanding, suppose I am taking a metal gun. Okay, it's a trigger, provide with a trigger, and then barrels. So everything is well equipped over this, right? Simple it is. It's a gun. We call this is recoiling of gun. Recoil of gun. Yeah. So coming to the point. So suppose, for example, any external agent, of course don't consider that it is external force is acting on the system, so that after triggering it, then what is happening? The bullet from the gun itself comes out of it. Okay, so before that we will see the gun is not moving at all, it is at a same place. Therefore we can say what is the initial momentum, such as that is pi. So that momentum initial is nothing but mass multiplied by the total mass of the entire system. Okay, mass multiplied by velocity, which is obviously nothing but 0, because you see that system is not moving initially. So therefore we can simply understand without a formula the initial momentum of the system is 0. Clear? That is then formed. And once it is triggered, then what is happening? The bullet will comes out. bullet will comes out with a large, well, being it is its mass is, I'm choosing, this is the mass of bullet is small m, and then velocity is much more because being it is very small in size. So that what is happening, the bullet will comes out of the gun with enormous speed, even that it can penetrate through the human bodies, even it can penetrate through the strong solids like wooden planks, etc., etc., etc. Depends upon its mechanism of working. Yes, anyways, that is the velocity with which the bullet is coming out of the barrel, it is means pistol, it is v, and the mass of the bullet I have chosen, it is 2. And then what is happening, where does this velocity is produced? To that bullet itself, being it is a part of the system. Initially the system is at rest, then it is provided with certain greatest velocity to come out of the gun and even can penetrate to the strong bodies. So therefore now we'll see where does that mechanism inside the body may be providing it, and what does this conservation of momentum is balancing here. You see, it is very seriously advisable to the defense trainees. Then what is happening while shooting and the training of shooting, then they are strictly asked to carry the back portion of the gun on their shoulders, such that like this. Once it's triggering, then what is happening, we will see that gun will be jerking backside. If it is against to the face, then what is happening is going to hit the face, and the person may be obviously be damaged. So in order to avoid that, what is they are advised to carry the back portion of the gun to the shoulders. Even if it is recoiling, then what is happening, it is going back. So what is happening in this as far as our physics concerned in this working of this machine gun, so that once this triggering, that bullet will is coming out of it, and then due to that, even you can say that Newton's laws of motion, third law of motion, so that action in forward direction, then reaction will be backwards. Okay, so that is what is actually happening. We simply call that is recoiling of gun. And now how we mathematical approach of this conservation of momentum will be exhibited in this situation. We will take that initial momentum of the body is 0, that is very clear to us. And now what is happening, while the bullet is coming out with greater speed velocity having mass small m, and then the gun, according to Newton's third law, for this action, reaction will be in backward, that is what actually we call recoiling of gun, but no external force is acting. That is what we are all concerned about this topic. No external force is acting. So therefore, and that system's momentum after this process means triggering out, coming out, bullet is coming out, that it entire must be balanced. So that according to our principle, momentum initial is 0 and must be equals to momentum final. So therefore final momentum also must be equals to 0. But what is happening here? So that let us calculate the final momentum with our mathematical approach and the conceptual understanding too. Then we will formalize that what is happening finally. So that initial momentum obviously it is 0. Then final momentum, see that there is a momentum for the bullet itself. That momentum I am writing mass multiplied by velocity of the bullet. And even there is a momentum for the gun itself, that is what actually we call recoiling of gun, it is moving back. And then mass of gun, as it is considerably more as far as the size of bullet is concerned, and that is the reason we have taken it is capital M. And then velocity, which we shall take, that is capital V. Don't consider that capital V is bigger than the smaller v, maybe it is having more velocity magnitude, not at all. So therefore this is the final momentum of the entire system. It must be equals to initial momentum of the entire system. That is what the balancing of law of conservation of energy. Due to this, we are going to calculate that mass multiplied by velocity of the gun plus mass multiplied by velocity of the bullet is going to be 0. And if you want that velocity of the bullet, you can simply transfer this term to the right side. We will get that v equals to negative mass multiplied by v upon small m. And this is a very useful equation in calculating velocity of the bullet which is coming out of the barrel itself. And even we can calculate the mass of gun and even velocity, recoiling velocity of the gun, and that negative sign it is clearly indicating action and reaction are opposite to each other, acting with two different bodies. That is very well known basic fact for us. So that negative sign it is indicating bullet is going in one velocity in one direction, that recoiling velocity is opposite to that. So that's all about that simple application of conservation of momentum. I hope that it is clear to you all. Okay, it is very useful, and some more applications regarding this concept are also available. So we will see in later videos. Thanks much for watching. This is Physics Satish. Okay, right. Namaste.